This is the second section of the correlation chapter in the Applied Year 1 book, and this is a linear regression. So before I go through all this stuff, I can just tell you in one sentence what linear regression is. Okay, so it's the equation of the line of best fit, basically. That's basically what it is. But we don't draw on a line and work out the equation of that line. This is done mathematically by using a formula. You don't have to do it in A-level anymore, but it minimizes the distance between all the points that have been plotted on your scatter diagram. So these are points that are plotted on our scatter diagram. And what the formula does is it says, right, okay, let's make these distances between our line and all the points as small as possible. And from that, we get our equation of the line of best fit, okay, what we call the regression line. And we always do what we call the regression line of y on x. Basically means we look to minimize the distances in the y direction. Yeah, these are all like little y distances here, and we make those y distances as small as possible. Yeah, so you don't need to calculate it. Your calculator can work it out for you. If you type in the values on your calculator, and I'll probably show you how to do that in a moment. But we just need to comment on that, the values we get in that regression line. Now, when we work out this regression line of y and x, it's basically going to be the equation of a straight line. So y equals mx plus c. Now we need to interpret those. So you don't just say it's the slope and the intercept, okay? The way I suppose that we write it is y equals a plus bx, okay? A tells you the value when x is 0, okay? So the value when x is 0. So interpret this in the context of the question. And B, this number tells you how much y goes up every time x goes up by 1. And again, we need to interpret it in the context of the question. Now, because it's like the equation of this line of best fit, if this value here is positive, okay, it means we have a positive correlation. So if B is greater than 0, it means that we have a positive correlation. And if B is less than 0, it means we have a negative correlation. Okay, so in this example, all of the data from this scatter, or from this table, has already been plotted for us in this scatter diagram. The first thing I need to do is I need to write down or describe the correlation. Now, if I were to draw a line of best fit, yeah, can you see how close all of those crosses would be to my line of best fit? So I would say that this is a strong positive correlation. Yeah, so that's my part A done. Part B, it says the equation of the regression line of G on W for these 15 days is G equals 7.23 plus 1.82 W. So the first thing is, what does this G on W mean? Well, that sort of matches up with our Y on x that we said before, the regression line of y on x. G is like our y, because that's what's on the y-axis, and w is like our x, because that's what's on the x-axis. And it says give an interpretation. Interpretation means that your answer must be in context. Yeah, in context. So we've got to be using words like daily mean wind speed and daily maximum gust. We've got to be using those words for it to be in context. And we need to give an interpretation of the gradient. Now, from before we talked about what the gradient means. Okay, it means for an increase of 1 of, now before it was x, wasn't it? So it'd be an increase of 1 of w, g increases by 1.82. So we've got to give an answer in context. So that answer is going to be like this. As the daily mean wind speed increases by 1 knot. Yep, use the units that it has. The daily maximum gust increases by 1.82, and what units are it? Knots. That's what I mean by an answer in context. Interpret the numbers in the context of the question. And then part C says justify the use of a linear regression line in this instance. In other words, does it make sense to work out the equation of the line of best fit? Justify it. Well, look at how strong the correlation is. I would say yes. So I would say since there is such a strong positive correlation, this justifies the use of a linear regression line or model. Yeah, because it makes sense to work out the equation of the line of best fit because the points almost lie in a line. There's a very strong correlation there. Right, the head circumference y and the gestation period x weeks for a random sample of 8 newborn babies at a clinic were recorded, and they're all here in this table, and they've been plotted for us here in the scatter graph. It says the equation of the regression line, basically line of best fit, is this. The regression equation is used to estimate the head circumference of a baby born at 39 weeks and one born at 30 weeks. Comment on the reliability of these estimates. Right, let's find on our scatter diagram or scatter graph here 39 weeks. Now 39 weeks, if I was to read off, would be reading off here. Okay, that's right in the middle of, well, not in the middle, but it's in amongst all the other data that's been collected. Now 30 weeks, right, this is nowhere near any of the data that's been collected 30 weeks down here. Yeah. How do I know that it carries on like that? It may be that all of a sudden drops off. I've got no idea. Okay, so right, so I would say, yeah, we can estimate at 38 weeks. We can use the equation at 39 weeks, since this is in the range of the data collected. However, that's not a very good however. However, 30 weeks is outside of the range of data collected, and since it's outside of the range of data collected, we've got no idea whether that line is going to carry on the same. It may curve round. So it's because it's outside the range of data collected, we cannot be sure the equation is still reliable. Okay, you might want to talk about, use the word extrapolate, which means try and find a value outside of the range, whereas when we're doing stuff inside of the range that we've collated, we call it interpolate. Right, a nurse wants to estimate the gestation period of a baby born with a head circumference of 31.6. Explain why the regression equation given is not suitable for this estimate. Okay, well, the equation is where you put the gestation period in to get the head circumference. Doesn't necessarily mean you can use the equation backwards and use the head circumference to work out the gestation period. This is the equation of the regression line y on x. Okay, so I'll just put we shouldn't use the equation to predict head circumference from gestation period, because the equation was derived from, I'll just put from the opposite. Yeah, it was derived from the opposite. In other words, the equation came from looking at the gestation period and measuring the head circumference, not from measuring the head circumference and then working out what the gestation period was from that. Right, you should now be able to do exercise 4b on pages 65 to 66. Before we do that, just a little talk about what we should plot on the x and y axis and what they're called. Right, the data that we plot on the x-axis, the label that we put on this x-axis, that data is called the independent or explanatory variable. The data that we plot on the y-axis we call the dependent or response variable. Now, why is that important? Well, what it does is it tells us that whatever data we plot here on the x-axis, whatever that label is causing this one over here to change. Okay, so it works that way around. Stuff that's on the x-axis is causing the stuff on the y-axis to respond to it, change because of it, not the other way around. So we just did a question, and that was to do with gestation period and head circumference, and I think we had the gestation period here, and on this axis we had the head circumference. Now they were plotted that way round. Gestation period was x and head circumference was y, because the gestation period causes the head circumference to change. Okay, so depending on how long it was before you're born will change your head size. It doesn't work the other way around. So it's not that your head circumference makes you stay in the womb for longer. That's why we couldn't do that part B of the question, because we can't work that way around.